Here's pre-calc. Here's your lecture for 9.1.1. It's matrices. We talked about if you add two matrices, you can just add the components. And so now we're on 9-2, and we're going to learn how to multiply. So Bullseye just sent in their order for this week. They want 20 cars and 25 trucks. Otto has asked you to determine how many special parts will be needed to complete this order. Begin by making a 1x2 retailer by vehicles matrix to represent the number of cars and trucks Otto needs to build to fill this order. Label this matrix B. Make sure you label the row and columns. So Bullseye wants 20 cars and 25 trucks. And they want a one, it says make a 1x2. So that's one row and two columns. So rows go horizontally and columns go vertically. So since they want 20 cars and 25 trucks, there's our matrix. Write matrix A to the right of matrix B and calculate the total number of wheels, seats, and gas tanks requested. So if you don't remember matrix A was, we were working with it on the previous problem, and it had how many wheels and seats and gas tanks you need for cars and how many you need for trucks. So that's where that's coming from. So A is the original vehicle by parts matrix, and we're trying to find out how many total wheels, total seats, and total tanks we need for Bullseye, because they want 20 cars and 25 trucks. So the wheels for the cars and the trucks, it's the same size wheels. It's just that every car needs 4 and every truck needs 6. So what we're going to do is we're going to multiply. Remember, we'll write BE for Bullseye. I don't like my pen. And 20 cars. So I need to find the total amount of wheels. So I'm going to go to the wheels column, and I know that I need 20 times 4 wheels to take care of all the cars that they want to build. But also I need 25 times 6 wheels for all the trucks they want to build. So it's kind of like I'm going to go 20 times 4, and I did the calculation right here. 20 times 4, and that gives me 80 wheels. That's going to cover all the cars. But then I go not 20 times 6, but 25 times 6. Because that's how many, because they need 25 trucks, and each truck has 6 wheels. So 25 times 6. So I get 80 plus 150, and I just added them up, and I got 230. That's the total number of wheels. So it's kind of like I multiplied row 1 by column 1. Or no. Well, it's like I multiplied the cars by the cars and the trucks by the trucks. I multiplied 20 times 4 plus 25 times 6. So we'll do the rest of them. So now I want to know how many seats altogether. So how many cars does Bullseye want? They want only 2 cars, or sorry, they want 20 cars, and I only need 2 cars. I only need 2 seats per car. So it's going to be 20 times 2 plus 25 times 1, and I wrote that right here. 20 times 2 plus 25 times 1. So 40 plus 25 is 65. That's the total number of seats that's going to build all their little cars and all their little toy cars and their little toy trucks. Okay, so how many gas tanks? So Bullseye, they want to make 20 cars, so they'll need 20 gas tanks, because 20 times 1 is 20. and then they want to make 25 trucks, and each truck they make has to have 3 gas tanks, so it's going to be 25 times 3 is going to be 75. So this one you can almost do it in your head. It's going to be 20 plus 75, and I wrote it all down here. And it's 95. So it's like, well, let's read. We're going to kind of study like what we did here so that we can get a general way of multiplying. So it says, discuss with your team how the computations you made in part B are related to matrix A and B, and then record the number of wheels, seats, and gas tanks Auto needs to complete the order in a 1x3 matrix. Call this matrix C and label the rows and columns. So I think I'm going to name this matrix C. And I already labeled it wheels, seats, and tanks. You'll notice, let me do autofocus. You should notice that I had a 1x2 because we go row first. Like when we list the dimensions, we say row first and then we say column. So this has 1 row and 2 columns. This has 2 rows and 3 columns. And notice that, see, this is row, column, row, column. Notice that the column of the first one is the same as the row of the second one. And notice that our product matrix is a 1x3. So it's 1 row and 3 columns. So just keep that in mind as we move forward. Let's read 9-3. It says, in the last problem you performed an operation called matrix multiplication. To calculate the total supplies needed, you multiplied matrix B by matrix A to get matrix C. Algebraically, it looks like B times A equals C. Write the problem again as an equation that shows the product of the retailer by vehicles matrix and the vehicles by parts matrix equal to the retailer by parts matrix. Describe the steps needed to determine each of the entries in matrix C, including what each number in the matrices represents. Pay close attention to the labels on the numbers you multiply, number of car times number of wheels, etc. Okay, so they're basically saying pay attention to where these numbers came from and what these numbers are. Like this 230, this is the total number of wheels. And so it came from the multiplying the car, how many cars by the number of wheels per car, plus how many trucks times the number of wheels per truck. And so all this came from this column and this row. And then this 65 came from, you know, this column right here and this row. And 95 came from, well, they all came from this column because there's only one column and this row. And if that doesn't make sense, we're going to do one that has more than one column so that you'll see that you have to match your rows and your columns together very carefully. And I only have like 1 minute left in my time, so we'll try to do it pretty quickly. 9-4. 9-4 says, suppose a retailer requests X cars and Y trucks. Compute the matrix multiplication in terms of X and Y, representing the number of parts needed, and the retail by parts product matrix in terms of X and Y. Okay, so I have it right here. So if this is the wheels, and this is the seats, and this is the gas tanks, I'm going to go X times W plus Y times, well, X times, it's going to be 4X plus 6Y. Let's just write it all down. And then in the next one, it's going to be 2x plus y. And then the next one is going to be 1x plus 3y. So it's kind of like the 4 and the 6. It's like you go x times the top one and y times the bottom one. X times the top one and y times the bottom one. X times the top one and y times the bottom one. Okay, so let's try this. I've impressed Otto with my use of matrices. There's more work to do. So now I'll let you read this out of your book, but basically now they're adding that there's J.C. Penney's want some cars and trucks, or J.C. Nichols, and so I set it all up. So this is bullseye. Remember they wanted 20 cars and 25 trucks, and J.C. Nichols wants 15 cars and 30 trucks. Well, you'll read that when you read the problem. So, and this is just my, remember this is the wheels and the seats and the gas tanks. So I want the number of bullseye wheels, the number of, like, across the top I'm going to have all the numbers for bullseye, and across the bottom I'm going to have all the numbers for J.C. Nichols. And I see that I have to make a second video because I'm not going to be able to do it in time. So I'm going to make part 2 after this.